This is lesson 14.3, part 3. In this part, we're going to find measures of angles in a right triangle. First, we'll try this application. It says an airplane's angle of descent into an airport is 3 degrees. So the plane is flying along in this direction, and it's going to descend to the airport. So if this is the airport here, this would be a 3-degree angle of descent. If the plane begins its descent at an altitude of 5,000 feet, so it's 5,000 feet above ground here, we would like to know how far is it in a straight line to the airport. So we're looking for this distance x. So based on your knowledge of geometry, you should know that the direction the airplane's going before it begins its descent and the ground are parallel lines, and the angle of descent makes a transversal. So if this is 3 degrees up at the top left, then alternate interior angles are equal, so this would be 3 degrees at the bottom. So we're looking for x. We have the two legs of the triangle, which means we should be doing a tangent. So tangent of 3 degrees is going to equal 5,000 over x. Multiply both sides by x to get x out of the denominator, and then divide by the tangent of 3 degrees. That will solve for x. So we get x equals 5,000 divided by the tangent of 3 degrees. And that you can put in your calculator. And we get that the distance a plane has to travel in a straight line would be 95,406 feet if we were to round it to the nearest whole foot. Okay, here we have a generic triangle again, triangle DGH. And it tells us angle H is the right angle, so we'll just randomly pick one of the other angles to be D, and then the other one is G. So in this right triangle, small h is 13, so small h would be the side across from the angle H, so that's 13. And small g is 5, so across from angle G is 5. So we want to know the angle of measure D here. Since we're looking for angle D, and we have one leg and the hypotenuse, and the leg we have happens to be the adjacent leg, we should do a cosine. So the cosine of D would be equal to 5 over 13. And then we can solve this by doing an inverse cosine. So we would end up with D equals the inverse cosine of 5/13. So you can put that in your calculator. With my calculator set to degree mode, I get D equals 67.3. Since I'm in degree mode, this would be a degree. If I set my calculator to radian mode, I would get an answer of 1.18, but this would be in radians, so you have to choose which one you want. Okay, as our last example, let's imagine that we are building a wheelchair ramp, so the slope is not more than 1 inch of rise for every 1 foot of run. First of all, you should notice we're using two different units here, and we should convert. So 1 foot is equal to 12 inches. So let's do that and keep it in inches. So now we're looking for the angle theta. Since we're given the two legs of the triangle, we would want to use a tangent here. So the tangent of theta would be opposite over adjacent. And then we can calculate for theta by taking the inverse tangent of 1/12. So that you can put in your calculator. It tells us to measure in degrees, so make sure your calculator is set to degree mode. And we get 4.8 degrees. And that concludes lesson 14.3.